Okay, hello everyone. As we're looking at the hexagon table problem real quick, as I drew a picture of two tables and see how many people could fit there. I counted around, there's 10 that can fit with two tables. So I started filling this out. We saw 6 here at one table, that's 6 right there. With two tables, we found 10. 3 tables, I count right there, there's 14 people. So I can see it's going up by 4 each time. Every time we add a table, we eliminate this one right here. We add 2 on this side and 2 on this side, and then add that one back, okay? All right, so it goes up by 4 each time, okay? Went ahead and graphed it. It looked like this. All right, went all the way up. I got, for 20 tables, it was right about 82. Again, it goes up by 4 each time, so the slope is 4. All right, and if you come all the way back down, think of it when the number of tables is 0. Where does that line cross? It doesn't quite cross at 0. It crosses at 2. And think of it like this, guys. We went down from 14, down to 10, down to 6. If I went down 4 more to 0, I'd be at 2. All right? Those 2 people are the 2 at the end. All right? They're always there. As we add tables, we're just adding 4 more on the sides is what we're doing. All right, so here's our formula. Y equals mx plus b. It's 4x plus 2. That's the equation of this line. All right? Guys, we can solve this for x. All right, because rarely, if you're like a caterer and you're having a wedding or something, they don't come to you and say, you know, get so many tables. How many guests can I have? What they tell you is this is how many guests I'm going to have. And you got to know how many tables to get. All right, so they tell you the y. You subtract 2, divide by 4, and that's how many tables you need, okay? But guys, sometimes they don't have hexagon tables. They might have any number of sides. You can introduce a new variable and say, well, if n is the number of sides, all right? We had 6 sides minus 2 was 4, ended up being our slope. But any number of sides, again, if this was square tables, we're only adding 2 each time. All right, 4 sides, 4 minus 2. We only add 2 each time. And for a triangle, we actually only add 1 seat each time, okay? All right, that's it, thanks. Okay, hello everyone. Guys, this is the day 38 worksheet. All right, we're graphing linear equations in standard form. Guys, we're going to use the cover-up method. Again, we're going to find the intercepts. So first, I'm just going to cover up the 5x, because that's when x is 0. It just covers that up, because x is 0. So what we have here is 4y equals 8, which means y equals 2. Guys, so it goes right through right there, where y is 2. That line will go right through the y-axis where y is 2. All right, now I'm going to cover up the 4y as if y is 0. So I have 5x equals 8. Divide both by 5. X is 8 over 5. And that's 1 3/5. That's 1 3/5. It's right about there. Okay? Now look, I know I'm using equal signs here. I'm just looking for those points. I know we're dealing with an inequality here. We're going to get it here in a minute. All right, we got our 2 points. We're going to draw the line. It's a solid line because this says greater than or equal to. So I make a solid line. All right, then what we do is we test a point. I want to know, do I shade the top or do I shade below? Well, let's find out if 0, 0 is a part of the solution. 0, 0. All right, if this is 0, 0, x is 0, and y is 0, what does that mean? That means 0 greater than or equal to 8. Well, is 0 greater than or equal to 8? No, it's not. So 0, 0 is not in the solution. So this side is the solution, shade above. All right? Let's do another one. It looks very similar. First, we cover up the 5x just to find the points. I have 4y equals 12. Divide by 4, y is 3. All right, so 1, 2, 3 right there. Y is 3. It goes through that point right there. Then we'll cover up the 4y. So what we have there is 5x equals 12. So x is 12 over 5, dividing both by 5, both sides by 5. I got x is 12 over 5. Well, that's 2 2/5. So 2 2/5 is right about there, okay? So we have our 2 points. We can draw a line now. Guys, this says greater than, not equal to, greater than. So this is a dotted line. Remember, we're doing inequalities here, not equations. Dotted line. Then again, test 0, 0. Because we don't know, should I shade down here or should I shade up here? Test 0, 0. Again, is 0 greater than 12? No. Again, x is 0, y is 0, this side is 0. Is 0 greater than 12? No. So 0, 0 is not a part of our solution. So it must be up here. All right. We'll do another here. Again, cover up the 2x. This says negative 5y equals 5. So y must be negative 1. All right, so negative 1 is right there. All right. Cover up the negative 5y. It says 2x equals 5. Divide both sides by 2. X is 5 over 2. That's 2.5. So 2.5 is right about there. All right, we can draw our line. Again, it's dotted, because that just says less than, not equal to, just less than. So draw my line. Dotted. All right, let's test the point, 0, 0. If these are both 0, this says 0 less than 5. Is 0 less than 5? Yes. Yes, this is 0 is less than 5. So 0, 0 is a part of the solution. We want to make sure the origin is part of our shaded area. So make sure we shade above here so the origin is a part of our answer. All right, you know, look, I think you guys can do this. You can do this one. You see what I'm doing? And some of these are very easy, guys. Look at this one, 3 and 3. 3, 3. There's the 2 points. It's dotted line. Right? Test a point. Is 0 less than 3? Sure is. So 0, 0 is in the solution, so shade below. Well, I think you guys can get this. Here, this one here, guys, maybe it might be a little trouble. Again, that just says y greater than negative 5. Just here's y, and here's negative 5. All right? It's a dotted line straight across, guys. And y greater, everything greater, like that. Wherever y is greater, everything up here, y is greater than negative 5, anything up here. All right? I'm hoping you guys can get the rest of these. I think you can do them. Okay, I'll try number 9, the last one I do here. Again, you just cover up the 2x. So I have 3y equals 3. So y is 1. So right there. That's where y is 1. Cover up the 3y. 2x equals 3. So x is 3 over 2. That's 1.5. So x at 1.5 is right there. It's a solid line. Test a point. If these are both 0, this says 0 greater than or equal to 3. Is 0 greater than or equal to 3? No. All right, so 0, 0 is not in the solution, so it must be up here. All right, guys, you can always put this in Desmos and look right at the graph and see what it looks like. Put them right in Desmos and see what the graph looks like, okay? That's okay. All right, guys, I'm running out of time here, so I have to stop the video.